first question is again a very simple. What they are saying? They asked this problem in a 1994 AIPMT exam. In a rocket, fuel burns at the rate of 1 kg per second. This fuel is ejected from the rocket. See, one more concept. We are going to deal with that type of problems, that lift problems. One more concept we are going to discuss, that lift problems. What is happening when you are sitting in a lift or in a swing which is moving in upward direction with an acceleration a? You will feel heaviness. Your apparent weight will be m into g plus a. When it is coming downward with acceleration a, you will feel light. Your apparent weight will be m into g minus a. Due to change in reaction on force. That is due to that fact. So now we are moving towards this because in competitive, a very big chance to get problem on these two formulas. In different way they can ask. We will discuss. See, what is this? In a rocket, fuel burns at the rate of 1 kg per second. This fuel is ejected from the rocket with a velocity of 60 km per second. This exerts a force on the rocket equal to. We know that rocket propulsion is a good example of law of conservation of momentum. What was happening initially? Gases or fuel was the part of rocket and rocket was at rest. It means initial momentum was 0. Rocket was at rest. So initial momentum of rocket was 0. What suddenly happened? One part of rocket is coming out with a great momentum in downward direction in the form of gases. Actually, you burn the fuel, gases ejected with a speed. So, to make it 0, rocket will get momentum, same momentum in opposite direction. It is the principle of rocket propulsion. With the help of this, we will solve this. In 1 second, 1 kg fuel in the form of gases coming with a speed of 60 km per second. So, what momentum this 1 kg is gaining? Momentum of 1 kg fuel is equals to m into v. What is v? 60. Kilometer means 1000 meter per second. So this momentum fuel got in downward direction. So same momentum rocket will get in opposite direction. So change of momentum of rocket should be equal to this. (60,000 kg meter per second). Since this change occur in 1 second, so we can say it is rate of change of momentum. Because this happens in 1 second And you know that rate of change of momentum is force. So which force rocket will experience? 6,000 Newton. Enough to push the rocket. 60,000 Newton. So we are going with option B. Second, a man fires a bullet of mass 200 gram at a speed of 5 meter per second. The gun is of 1 kg mass. But what velocity the gun rebounds backward? Again the example of law of conservation of momentum. Initially, gun with bullet, it was at rest. It means initial momentum of gun with bullet was 0. Suddenly one part of gun means bullet. It got a momentum in this direction. To make it 0, gun will get a momentum in opposite direction. What is the momentum of bullet? Momentum of bullet is m into v. Take care of units. Gram is not in SI unit. So divided by 1000. Velocity SI unit. No tension. So we got 1000 upon 1000. 1 kg meter per second. So momentum of gun should be equal to this. Just in opposite direction, because momentum is vector quantity. To equal and opposite vector, sum should be 0. What was initial momentum? But if mass of gun is 1 kg, and suppose it got a velocity v, 1 into v should be 1. So v is 1 meter per second. So gun rebounds backward with the velocity 1 meter per second. So we are going with A option. Third, again from 1996, previous question was also from 1996 AIPMT. It is again from 1996 AIPMT. A 10 Newton force applied on a body produces in it an acceleration of 1 meter per second square. The mass of the body is, it is just like 9th class problem. Force is equals to mass into acceleration. So mass should be equal to force upon acceleration. Force is in SI unit. Acceleration is in SI unit. So we are getting 10 kg. So going with C. A force vector applied on a mass is represented as this and accelerates with 1 meter per second square. What will be the mass of the body? Again, they are going to check the combination of your two concepts. You know vectors, you know Newton's law. It is the combination of two. Just we solve. If you want to calculate mass, you should know force and acceleration. Acceleration is given, but force they gave you in vector form. But you know vector, how to calculate the modulus of a vector? So you are able to calculate modulus of this force. Under root coefficient of I square coefficient of j square, coefficient of k square. So what finally we are getting? Root 200 means 10 root 2. If everything is in SI unit, it should be in SI unit. They should give us this much Newton. So now it is easy for you. F is equals to m into A. So therefore A should be F upon m. A should be equal to F upon m. What is force? 10 root 2. What is the value of m? We want to calculate m. A is given. In this case, A is given. So we want to calculate m. So we can write it. And A is 1. So what we are getting? 10 root 2 kg. So we are going with A. We are going with option A. Fifth problem. A force of 6 Newton acts on a body at rest and of mass 1 kg. During this time, the body attains a velocity of 30 meters per second. The time for which the force acts on the body is. You know that initially body was at rest. What things are given? Initial velocity was 0. U was 0. Force of 6 Newton. Force is given 6 Newton. Mass. It is given 1 kg. Final velocity. It is 30 meters per second. We want to calculate time for which force acts on the body. The time up to which force acts on the body is the time the acceleration was present there. Force 0 means acceleration 0. You want to calculate up to what time your object was moving with constant acceleration. So it is motion under constant acceleration in a straight line, means clearly a problem based on Galileo's equation. A you can calculate from Newton's second law. F upon m. What is F? 6. What is m? 1. So we are getting 6 meters per second square. So we have A, we have U, we have V, we want T. First equation of motion, V is equals to U plus AT. So 30 is equals to 6 into T. This implies T is equals to 30 by 6 means 5 seconds. It means force was present for 5 seconds. So we are going with option number B. Next problem. A shell in flight explodes into 4 unequal parts. Which of the following is conserved? We know that what happens in explosion, only internal chemical reactions were taking part in that. So it was totally internal phenomena. And we know that according to Newton's second law, if external force is 0, momentum should be conserved. We know that what is force? It is external force, rate of change of angular momentum. And all of you know that differentiation of a constant is 0. If f is 0, it means p should be constant. So which term will conserve? Momentum will conserve. Now we are going to solve 7th problem from 1998. What is it? A 5000 kg rocket is set for vertical firing. The exhaust speed is 800 meter per second. To give an initial upward acceleration of 20 meter per second square, the amount of gas ejected per second to supply the needed thrust will be G is 10 meter per second square. So what we need in this case, see, it is a rocket. Initially it was at rest. So initial momentum it was 0. So final momentum it should be 0. So what momentum gases will get in downward direction, rocket will get in upward direction. What force we want to supply to rocket? Its mass is 5000 kg. Its mass is 5000 kg. It means its weight is m into g. Plus we want to overcome its weight. Plus additionally we want to give it an acceleration of 20. We want to overcome its weight. Additional we want to supply it an acceleration of 20. So this force for 20 acceleration, this force to compensate weight. So net force it should be 5 into 3 15 into 10 to the power 20 and 10 30, 3 into 5 15. So 30 and 10 of this 30, this Newton. So it means we know that rate of change of momentum is equal to force. It means in 1 second change in momentum should be equal to this. So if in 1 second, let in 1 second m kg gas ejected. So in 1 second change in momentum of gas is equals to m into v. V was 800 meter per second. So law of conservation of momentum, in 1 second change in momentum of rocket, it should be same. It means force on rocket. Rate of change of momentum is equals to 800 m, but we need 15 into 10 to the power 4 Newton. Therefore 800 m, it should be equal to 15 into 10 to the power 4. So what we got m? 15 into 10 to the power 4 upon 800. Cancel 20 with 20. So remaining 1500 divided by 8. 8 ones are 8. 70. 8 8s are 64, 660, 8 7s are 56.5 kg. So in per second, gas ejected should be 187.5 kg. So kg per second. Mass, it should be this. Per second we need this mass ejected. So in this way, again we got one problem of rocket. In 96 we got one problem. Again in 98 we got one problem. So in next sheet we will solve now remaining problems. Thank you. So again now we are going to solve 8th problem. Again same type of concept is there. A force on a rocket having exhaust velocity of 300 meter per second is 210 Newton. Then rate of combustion of the fuel is. Again same concept is involved here. Initially rocket was at rest, its linear momentum was 0, there was an exhaust of gas. Due to this, one part of rocket got a momentum in this direction. To make it 0, rocket will get momentum in opposite direction. Suppose rate of combustion of the fuel is, let rate of combustion of the fuel is m kg per second. That is rate of change of momentum. Change in momentum for 1 second is rate of change. Is mv. Therefore, rate of change of momentum of rocket, rate of change of momentum of rocket, it should be mv, that is force on rocket. Force on rocket is equals to m into v, but they gave 210. So m should be 210 by 300, cancel 0 with 0. So we are getting 0.7 kg per second. So we are going with option B. We are going with option B. Next, it is from 2001 AIPMT. A cricketer catches a ball of mass 150 gram in 0.1 second, moving with speed 20 meter per second. Then he experiences a force of, a very simple problem. What is the force? Force is rate of change of momentum. Rate of change of momentum. Initial momentum of ball. It means mass into change in velocity upon time. Rate of change means calculation for 1 second. What was mass of ball? 150 gram, convert into kilogram. Change in velocity. You are making 20 to 0, not talking about direction. 20 delta t, time for this operation 0.1 second. So what we are getting, 150 into 20, 3000 upon 1000, 0.1 means 1 by 10. So we are getting 3 into 10, 30 Newton. So we are going with option B. Next, sand is being dropped on a conveyor belt at the rate of m kg per second. The force necessary to keep the belt moving with a constant velocity of v meter per second will be. Again, you are dropping sand on a moving belt, on a conveyor belt, in per second. How much change in momentum for that belt is there? Since belt was moving with velocity v meter per second, belt was moving, you drop something on belt. Again, there is a change in momentum of this. For rate of change of momentum or for this sand, belt need extra force. We want to calculate that extra force. So what is change in momentum of sand? Rate of change of momentum of sand is so rate of change of momentum of sand is equals to change of momentum in 1 second. In 1 second, you drop m kg of mass and it will acquire a velocity of v. Therefore, force to keep this additional force now belt require. So force to keep the belt moving with constant velocity is equals to m into v. So we are going with option C. Next, a monkey is descending from the branch of a tree with constant acceleration. If the braking strength is 75% of the weight of the monkey, the minimum acceleration with which monkey can slide down without branch is. It is the case just like lift. Monkey is coming down with an acceleration. It means its apparent weight which it is putting on rope will increase because lift is coming descending from the branch of a tree with constant acceleration. What he will get? He is coming down. So its apparent weight should be equal to m into g minus a. He will put a force on the rope of this order, m into g minus a. Lift is coming downward with acceleration a. Your weight will appear m into g minus a. If it is going in upward direction, m into g plus a. So now what they are saying, it should not exceed 70% of its weight, means 3/4 of its weight. What is monkey's weight? mg, because it is the breaking strength of rope. So if he is coming down with acceleration a, it means he is putting a tension equal to m into g minus a on the rope. It should not exceed this. Cancel this m with this m. So what we are getting now, g minus a is equals to 3/4g. So what maximum acceleration with which he can slide? G minus 3g/4 means g/4. So we are going with option C. It was problem from 1993 AIPMT. Next, a mass of 1 kg is suspended by means of a thread. The system is lifted up with an acceleration of 4.9 meter per second square, lowered with an acceleration of 4.9 meter per second square. The ratio of tension in the first and second case is again a problem matching with that left problem. When system is lifted up with an acceleration, tension should be in up m into g plus a. When lowered with a, tension should be m into g minus a. What we want to calculate? A ratio of T and T dash. G plus A. What is A? A is equal to 4.9 meter per second square, which is half of G. G plus A means G by 2 upon G minus G by 2. So 3G by 2 divided by G by 2. So what we are getting? 3:1. So correct answer is A, 3:1. Next, two masses as shown in the figure are suspended from a massless pulley. The acceleration of the system when masses are left free is, you can remember the formula directly. So again and again, no need for derivation. If you forget, make formula immediately. Weight is pulling downward, and in this case 10g downward. Tension is in upward. Since 10 kg is greater than 5 kg, so it will move in downward direction. With what acceleration it will move downward? It will go in upward with that acceleration only. If we are making free body diagram of 5 kg, net force on this is in upward direction and it should be T minus 5g. But according to Newton's second law, it should be 5a. And for 10 kg, downward force is greater than upward force. The net force is 10g minus t, but it should be 10a. We want to calculate a, so add these two equations. T will cancel out. 10g minus 5g, 5g is equals to 15a. So a is equals to 5g by 15 means g by 3. Next, it is from 2002 AIPMT. A lift of mass 1000 kg which is moving with acceleration of 1 meter per second square in upward direction, then the tension developed in string which is connected to lift is. Every year we are getting same type of problems. In this chapter, not a big variation is there. So if you are alert, you will get marks. See, lift is going in upward direction, so apparent weight should be greater than its normal weight. So tension should be m into g plus a. What is m? 1000 kg. What is g? If we are taking 9.8, what is a? 1. So 1000 into 10.8. Remove this decimal with 1 0. 2 zeros are remaining. So 10800 Newton. So we are going with B. We are going with option B. The coefficient of static friction mu s between block A of mass 2 kg and the table as shown in the figure is 0.2. What would be the maximum mass value of block B so that the two blocks do not move? The string and the pulley are assumed to be smooth and massless, and value of G is given 10 meter per second square. See, what is the actual scenario? Weight of this block, it is block B and that is block A. Suppose its mass is m. It means downward force should be m into g. It will produce a tension in the string. This tension will try to pull this mass, this block A. Frictional force will try to stop the mass A. If whole system is at rest, T should be equal to F. What is F? What is F? We know that F means mu into R. What is R? R is mg, because normal reaction is balanced by its weight, which is 2g. mg means m is 2, g is g, this. So it means the frictional force which is equal to tension, this is equal to 2 mu g. Now I am making free body diagram for this. Net force on this is also 0. From this, T should be equal to mg. So mg is equals to T, T is equals to F, means 2 mu g. Cancel g with g. So what is the value of m? 2 into mu. And what is mu? Mu is given 0.2. So we are getting 0.4 kg because we are doing problem in SI units. So we are going with option D. So D option was correct. It was the problem from 2004 AIPMT.